Okay, we'll conclude section 3.1 on functions with an application problem. They've given us a function here and a situation. If a rock falls from a height of 20 meters on the planet Jupiter, its height in meters after x seconds is approximately modeled by this function. Now, of course, on Jupiter, the gravitational pull would be a little different than on Earth, so this would not be similar to what we'd expect on Earth. So x is time in seconds. H of x is the height of the rock. And so it's falling from 20. So it starts up here on, I don't know, on some platform, and it's falling down, and the platform is 20 meters tall, right? Just to give us a general idea of it. So the question is, after 1 second, where is it? It starts at 20. So where is it after 1 second? So in other words, they're saying find h of 1. So that's 20 minus 13 times 1 squared, which of course is just 20 minus 13, or 7. 7 what? The question is, what's the height of the rock? 7 meters. So after 1 second, it started at 20 meters off the ground. After 1 second, it's 7 meters off the ground. Well, what about after 1.1 seconds? 20 minus 13 times 1.1 squared. Okay, so it should be closer to the ground, right? As we go a little bit longer, another 1/10 of a second. And when we square 1.1, multiply by 13, subtract that from 20, you get 4.27 meters. So it's a little closer to the ground now. And now at 1.2 seconds, 20 minus 13 times 1.2 squared. Using your calculator, you should get 1.28 meters. So in just 1.2 seconds, or 1 2/10 seconds, you're now just a little over a meter off the ground after starting at 20 meters above the ground. Okay, well, when is the height of the rock 15 meters? So in this one, we were finding height. They gave us time. Now they're asking us for time given the height, right? So what this is saying is x is what when h of x is 15? That's the question. If we put in 15 for h of x, what x would that have been? So let's plug that in. 15 equals 20 minus 13x squared. So let's see, I'm going to add 13x squared to both sides and subtract 15. So I end up with 13x squared on the left and 5 on the right, 20 minus 15. Divide by 13, x squared equals 5/13. And to find x, we'll take the square root of both sides. Now, do I want to do plus or minus? Whoops. Plus or minus the square root of 5/13? Remember that tip we just saw? It said it has to make sense, right? In an application problem, it has to make sense. So I'm only going to look for the positive result. This is time, this is seconds, and a negative would not make any sense for this problem. So now I take the square root of 5/13, and I get x equals, I don't know, let's go maybe 3 decimal places, 0.620. Okay, or about 0.6 seconds. So after about 0.6 seconds, it's 15 off the ground. Remember, at 1 second, it's 7 off the ground. So we know it had to be less than 1 second. Then they say to do 10 and 5. So let's see if we can fit those in here. X is what when h of x is 10? All right, so 10 equals 20 minus 13x squared. So 13x squared equals 20 minus 10, or 10. So x squared equals 10 over 13, taking the positive square root of that. And the square root of 10 over 13, let's see what I got there, 0.877, or about 0.9 seconds. Okay, so now we are, the height is we're getting closer to the ground. We were at 15 after 0.6. Now we're at 10 after 0.9. And remember, after a whole second, that's 9/10 of a second, a whole second, we're at 7. So we're at 10, then we go to 7, right? We saw that. And x is what when h of x is 5. So 5 equals 20 minus 13x squared. 13x squared, 20 minus 5 is 15. So x squared equals 15 over 13. And we take the square root. Square root of x squared equals the square root of 15 over 13. So x equals, and this time I got 1.24 or approximately 1.2 seconds. Okay? And our last question is, when does the rock strike the ground? Well, how high off the ground is the rock when it strikes the ground? It's 0 meters off the ground, yes. So x is what? It's saying when, and when is time, and time is x. X is what when h of x is 0. So plugging 0 into our function, so I get 13x squared equals 20. X squared equals 20 divided by 13. The square root of x squared equals the square root of 20 divided by 13. And x equals, oh, I think I messed up. X equals 1.24. So my last, I looked at my wrong notes here. This one would have been 1.07, 1.07, sorry. 1.07 or 1.1 second. Let's make that correction. Square root of 15 over 13, 1.07 or 1.1 seconds. And this is my 1.24 result, which is approximately 1.2 seconds. Okay? So that's an application of a function.